So thank you so much. It's really lovely to be here, and I have to say it's a bit of a time warp for me. I've been out of academia now for about 16 years, and so coming back and hearing all my academic work referenced is quite lovely. I have taken quite a path. I left MIT back in 2000. I joined a small startup company that came out of MIT. We were a bunch of ex-academics who really loved doing academic work but didn't really want to write the papers. I'd written enough of those. So we all worked on, for about 15 years, some really interesting, challenging problems around production systems, manufacturing systems, product development, et cetera. So as part of that, I got to work on the 787 and helping them form their variation risk management program there. To how to robustly assemble grain silos, to a great deal of work in the bike industry, which is a very different industry than in terms of its speed and its product and its rapidity. Got to work with small companies and large companies. About a year ago, I made the decision to change again. I get bored about every 7 to 10 years. And decided to start working in the startup space. It was an opportunity I got really tired of ripping out systems by the roots and trying to retrain people, and decided to try and brainwash them early. And yeah, so my goal is to have all these new startups actually build these systems in place from the start, as opposed to having to fix them when they reach $100 million. Now, I am a mechanical engineer, and I do electromechanical, but I can never figure out how these things work and where I'm supposed to point. There we go. So I work with a company called Dragon Innovation. Our goal is to take small startup companies, they finish Kickstarter, and we get them up into production. So these guys think they're done. They have got this beautiful ID model that's been 3D printed, and then something that you do not carry on an airplane, because somebody's going to think it looks like a bomb, because it's full of wires, and you press a button and a few things happen, and they think, oh, we're going to go into manufacturing and it's going to work. And we sort of disabuse them of that notion and help them get into production. So help them through the design process, the DFM process, et cetera. So part of my work has actually been a lot of fun. I get to actually work with these small startup companies. And part of my work is to take all these things that we're doing and start to productize them. I'm going to talk a little bit about that as well. So I've had a huge change of perspective. So since 2004, when the book came out, to now, I started my life in very large traditional companies that look a lot like a lot of the people in this room. You know, very risk-averse, systematic NASA-like approaches, large teams, people like yourself in the room who've got incredible deep expertise, a lot of gray hair in the room, very prescriptive, I cover mine, prescriptive product development with stage gates, etc., long cycle time, your design is locked early, and you have the resources to do those iterations. I'm now in the small hardware startup space where people are risk forward, it's seat of the pants, everybody's getting stuff done quickly, just get it done. A lot of late design changes in product development, a lot of build, test, build, test, build, test. And the academic in me, it made my head explode until I realized that I was reading all these articles about Toyota and GM having all these massive quality failures, and they had all these great people doing robust design. And yet I've got these small startup companies who are not doing things the way they're supposed to, but yet they're having these highly successful, beautiful products. And somehow they're doing it, but they're not doing it in the way we teach it. And it's been really an interest. So that's sort of the academic in me has been having an absolute blast trying to figure that out. So bikes, if you guys talk to me for more than 15 minutes, I always talk bikes and big cyclist. So it was really interesting sort of looking from the time that I wrote the book to now. The left was the Tour de France bike that happened when I started this whole path, and the one on the right is one that was ridden recently. And what's happening in industry in general is that there's been huge technology change. Just the sheer volume of technologies, materials, the integration has grown incredibly. In addition, the operational changes have changed considerably in terms of speed to market, your regulatory, how many product variants you're doing. But the interesting thing is this is happening with much shorter schedules and with a lot fewer resources. So you're having to do this incredible complexity without the luxury of time and people to be able to get it right. So there's this, how many of you guys heard about the hardware revolution, if you read about it? So there's this, yep. So the hardware revolution is something that I really wasn't aware of until I started working in startups. There's this huge, it came out of the maker movement, and there's this huge change that's been happening, probably the inflection point was about 2013, where new technologies such as rapid prototyping, Arduino, online CAD, infrastructure tools, all those things that as a large company we spend hundreds of thousands of dollars on, you can now get the simple version of them online for free. And so the barriers to entry for these hardware companies has gone to zero. And so what used to take years to develop and used to have a SMT line, and you had to have access to injection molding, you had to have access to all these things, these new hardware startup companies can just get them online now. And so the barriers to entering are incredibly low. Now, it may look like it's just little tiny electronics, and it's like your Pebble watch, and it's something that plugs into the back of your phone or into your car or whatever that is. But I was actually meeting with some hardware startups over at the Founders House, and there's a group that's actually doing an electronic motorcycle. And they figured out the supply chain, and they're going to be developing, they want to be the next Ducati for electric bikes. And it's 10 guys in an office. So these barriers to change are coming down. So really anybody can develop a product. So why is this important? How many of you guys read Clay Christensen's book on Innovator's Dilemma? If you haven't, go read it. It's really important. He's got this idea of disruptive technology, where technologies happen sort of in the margins, and they get developed in different spaces, and then they come and they eat your lunch. So it's sort of the laptop to what IBM used to be. It's another example they use is hydraulics to cables in heavy equipment. That there are these technologies that grow up, and I really have come to the conclusion that there are a whole range of technologies around product development that are in and of themselves disruptive technologies that are kind of growing and developing these small industries, but eventually are going to mean that these small companies and their ability to be incredibly nimble and fast will end up starting to eat away at the business of some of these larger companies that have a lot of overhead, have a lot of infrastructure. So why is that important to Robust Design Day? Well, for these companies, robust design becomes even more important. Like the importance of it, and this is something that's one of my agendas that I didn't bring up with my CEO. He doesn't know it. You guys know it. He doesn't know it. I want to brainwash all of these young engineers to figure out how to do this in these small startups without the advantage of having, the 30 years of experience. So we've been talking about robust design for 20 years, and companies still struggle with it. I find it, I always joke that I have infinite employment. I will be able to pay for my child's college education. My grandfather worked for International Harvester, and he wrote articles about this 30 years ago. And at first I was very depressed, and then I'd realized that I always have an income. So it's, we've been talking about this for so long, but we are working in a space that's getting more and more complicated, more and more pressure. The complexity is increasing. And most importantly, and I think this is the last bullet point, and I think everybody who's talked so far has really talked about this, is products are being developed by much younger engineers who don't have that experience, who don't have that knowledge. And the function of this product is being developed by people who do not understand the word robust, don't understand what variation is, don't have that training, and aren't getting it. So the question is that, how do we do that? How do we give them that capability? The problem is that with this growing complexity, it's not possible to look at all the interactions and all the possible sources of variation. You just can't do it. You can't create that KC flow down for the whole product. We were having a talk today about this with the wind turbines. is there's just not enough hours in the schedule. There are not enough people. And so the trick becomes not so much how to do the robust design, but where to do the robust design, and how do you begin to downsize that. And I think the best engineers in this room know how to do that intuitively. Like, we know after tons of years to be able to look at a product and go, I don't know why, but I know that's the problem. I mean, I'm sure you've got that experience as well. You can just look at it and you just kind of get this sinking feeling in your stomach when you look at parts of a drawing. So how do you begin to look at that? So the question then becomes, how do we, and I wanted to retitle this, right-sizing variation risk management. I wanted to call it Perfection is the Enemy of Completion, as sort of the subtitle. So we were all trained in this world. That's the basis of all of our education. Our education came out of the Sputnik NASA era. That's the way we were trained. When I learned risk management, you went through and analyzed everything. It was based on the space systems. You had this idea of model everything, test every source of variation, and everything is evaluated. Now, the kids that come to see me, who are all 12, see their contract manufacturer as a high-tech 3D printer. They think they can literally put a sketch on a piece of paper, kind of go, this is sort of what I want, and here's a video. And somehow a magic button gets pressed, and 1 month later they get this beautiful product that is of an Apple quality. So that's not feasible anymore. That's not realistic. So where is that? So the trick is what is that right size? So where do we sit in this? And what are those key aspects that we want to keep? And what do we want to not necessarily ignore, but what can we postpone, or what's going to be in the biggest focus? So if you look at the way sort of some of these software tools are coming about that are supporting the hardware evolution, or all these techniques that are supporting the hardware evolution, they have two aspects to them. One is they strip away everything. Sort of the difference between Word and Google Docs. Google Docs gives you 90% of what you need with about 10% of the features. And the other thing that the tools do is it's what's called progressive disclosure. And what that is that instead of saying to somebody, you need to do robust design, and they go, I have no idea what that is, and I don't have time. It becomes a series of progressive disclosure, which is, I'm going to ask you a question you can answer. How many of you have ever done taxes in the United States? No. Okay, how many of you have ever heard of a program called TurboTax? Okay, so one person. So this works much better stateside. So U.S. taxes, we won't get into U.S. politics. I could rant forever. It's the same thing. So TurboTax is this great program. It used to be you get the stack of files that you had to fill out, and it was incredibly complex, and everybody left it till April 14th because it was painful, and all the parents were really grumpy the next morning because they had to fill out all these forms. It was complicated. What TurboTax did was they created this thing of progressive disclosure, which they come up with a big screen that says, do you have a piece of paper that says W-2 on it? Yes. Pick up that piece of paper and look at box 1A. Type the number in 1A here. And they walk you through in a very, very succinct way. And so think about, what would that look like in robust design? So how could you, with your teams, create this idea of progressive disclosure to ask them questions that they can actually answer? So when I develop my quality plans, it's very much, who uses your product? So does it sit on a countertop or does it sit on a wall? How many times does it get moved from a countertop to a countertop? Okay, well, that sets your drop height tests. You know, if I ask them, tell me what your specs are for your drop test, they'd go all wobbly on me. But if I can ask them a series of questions that get them to that point. So that's really sort of where we are going with it. So, you know, what are those tools? And this is something that I'm figuring out right now, and anything you guys can do. I think this is going to be the future of it. It's not going to be this perfect, detailed Taguchi model, but it's going to be what gets you there easily. So, you know, and the key items are, you know, how do we do early and frequent prioritization of high-risk items? How do we prototype? And prototyping can be physical or it can be computational. How do we do comprehensive verification validation in pilots to do it quickly? We talking about on the that you were just talking about doing that very quick verification. I think you were talking about the W in Jaguar. So how do you do that bouncing between what do we have and can we verify it very, very quickly? And then very important, and this is a skill that needs better training, is really good root cause analysis and getting teams, and how do you train teams to stop and really do that root cause analysis well. So what do we do? So I'm kind of flying by the seat of the pants at this point, and I have only a set of tools that I can use. I can't bring robust design in. They can't imagine it. The schedule is going too fast. So I have to kind of joke about it's sort of like when I had to get my kids to eat broccoli, I had to bury it in cheese. So I have to kind of bury robust design under a lot of cheese to get them to eat it. So this is the way I bury robust design. I bury the vegetables in their dinner. So the first one is around warranty analysis. Actually, I'm going to go back. And I'm only going to touch on a couple of these. So the first is around warranty analysis. And I'm going to talk a little bit about how this can be large companies and small companies. We do a huge amount of DFM and DFA. We don't make them do that. We've got amazing DFM people, and we just do it. One of the techniques that we're seeing a lot right now, if anybody, there's a really cool new company called Protomold. It's really neat. And what they've done is that they have, basically you upload a CAD model to their software system, and they will tell you what's not manufacturable. So you won't be able to get a perfect part, exactly what you want, but it will be manufacturable. And then you can turn around and get your parts in a relatively short period of time. So you can actually get production intent injection molded parts. Now they're not going to be able to cut the edge of technology, but what they've done is they said we're not going to have, and it's all computer based. We're not going to have a tooling expert. We're not going to have an injection molding expert. We're not going to have all this capability and these graybeards that we're supposed to have in our company to be able to do this with these hundreds of years of experience. We're going to get you 80% of the way there so that you can get, and then once you have that, that's where you begin to learn. So it allows people who have no knowledge of injection molding to get injection molding parts without having to talk to an injection molding expert. And so there's sort of, if you think about what would that be for robust design, is there an equivalent there? So, we currently do a lot of the DFM, DFA stuff, just, again, using our expertise. We're starting to put a lot of that in software. I use this term called the pre-mortem. I spend a lot of time with big companies doing post-mortems on why the product failed. Now we try and imagine how the product had failed at the beginning. And we pretend like we're at the end of the failure and why it happened. So we're going to talk a little bit about that. Quality planning, this is my cheese on the broccoli. And then we have amazing project managers in China that just do an incredible job. And we just can't replace those. So warranty analysis, analytics. So it's very hard from the ground up to say how can everything fail. We just start with how has it failed. And what I tell my customers to do is I say go to Amazon, find all of your competitive products, and read every single one-star review. Yeah, it gets you pretty close on what's going to be a problem. What do people complain about? What do they not complain about? We also do, as part of my second career, did a ton on warranty analytics and how to use warranty analytics to do predictive models for the future. So how do you take historical data and then look at how your new product is going to be and then basically do a scaling on your warranty analytics to say whether it's going to go up or down based on increase and decrease in robustness. There's not enough time today to talk about that. And then the other one is common causes of recalls. I asked them to go read the CPSC databases to see how other products have been recalled. Warranty analytics are, if anybody wants to talk this, I can talk blue in the face on this. This is what I spent a lot of my last 15 years on. And these are different industries that I've worked in. Depending on the type of industry, you have to be very specific about how you analyze the data. And there's no one software program that I think is available for warranty analytics because it does have to be so industry specific. So the pre-mortem. So this is a technique I developed when a number of my companies kept having the same failure and the same causes over and over and over again, and it was great. It paid my mortgage for about 6 months. But, I mean, I don't want to do that on the back of quality problems. I'd rather prevent them. So what we did was we went through a whole bunch of these cases and figured out what were those root causes? Like, what were those things that were causing people to have defects, or where they were making products that were not robust? And they were things like new user groups. You know, they had a new set of users, a new set of customers, same product, different application, and they really didn't understand that. Or the tight physical space. I call it the 10 pounds of potatoes in a 5 pound, I should say 10 kilograms of potatoes in a 5 kilogram sack. In that tight physical space. So they take a product and they're trying to mash it into a much smaller space. That creates a whole bunch of problems. New technology, not having a good delta analysis. So what we found is that in a lot of the companies I worked in, that every different product would be a unique combination of these. But the superset was always the same. And in fact, we have in one of my clients, my prior clients, they now have they go through this and they do a checklist. And if it has more than 5 checks, they have a design review to see whether or not the product should be postponed until they reduce the risks. And they get more data. So it's a way of stopping products before it comes in. But more importantly, it really gets the teams to think about and highlight what is it about this that's going to drive the robustness of the product, and what do we really need to investigate and understand in each of those areas. So instead of having a long list of 40 things they have to do, they highlight those 5 critical ones that they know have caused them problems in the past. So the quality planning, this is the broccoli. So oftentimes now with these startup companies, the quality plan's the first time they actually have to write something down. You know, it's all in this cloud, and it's all in 3D and all in Box. I mean, they don't have PLM systems, they have Dropbox. And this is really the first time that they have to actually write numbers down about their product. They haven't had to write them down before. And so what we're doing is we're trying to get them to think about their quality plan earlier and earlier and earlier. And they know they have to have a quality plan, and they know they need to do it early, and so it gives us the opportunity to start asking those questions around robustness. So, you know, what do your steps and gaps need to look like? What do your surface, is this an Apple quality product? Is this a Kindle quality product? Is this a electronics in a box quality product? Do you have to see it? What's the look, feel? And then we help them begin to translate that into actual quantified requirements. But again, that sort of progressive disclosure of asking them questions around the quality plan. So we sort of hit them on the life testing. You know, what does the durability of this need to look like? And that starts getting them to have that conversation about, oh, okay, so how often is this going to be hit? You know, is it going to be dropped? Is it going to be loaded? You know, how many times is somebody going to be doing this? Are there parts that are going to get dirty? Are there parts that are going to wear? And so we use that as having the conversation. And I would get nowhere with having that conversation if I said, you need to write down your requirements. They're not going to do it. So we come at it from a very different direction. So what are those critical elements and precepts of robust design that should be in this? So let's ask that question. So again, these are the things that I have to get at, but I'm finding, again, I'm having to come at it from different directions that I'm used to, because there isn't somebody in the company that speaks my language. You know, what are the product goals and needs? Where is the variation risk the biggest? These are the big questions. Like, what is it that, you know, we can't deal with all of it, so what are those 4 to 5? You know, identifying those risks early and getting them to design around it. So right now I've got one where the ID designer wants a mold, a finish where it's like a flat piece and it comes in and it comes at a back angle, and we're really concerned about that flash. And so we know that that flash is going to be a big issue, and then the alignment of the piece is going to be a big issue. We know the steps and gaps are going to be a big issue. And so we're bringing that up right now within the context of the aesthetic quality requirements. Tuning the parameters to dial in the design. Again, that's another good example for that. Getting them to think about tolerances and process capability. I'm amazed at how many drawings go into production with no tolerances on them. For the academics in the room, teaching tolerances is really good. Again, and also testing to find problems. In a lot of cases, because the barriers to entry for getting that first prototype out and getting that production intent prototype out has become so much smaller, it's feasible to do that build, test, but testing with production intent. And then finally, the good root cause and corrective action. So I would ask you guys to think about, what is, in 5 years, is there something in this variation risk management world or the robust design world that's going to be the equivalent of SketchUp? I don't know if you guys have used that. It's the online CAD tool, or Google Docs, or Protomold. So what of this huge body of knowledge that we all have in incredible detail, what are those critical few, and how do we get our engineers to eat the broccoli and do this in a way that allows them to be successful, but in a way that does not require them to learn massive software programs, does not require them to have incredible courses, but allows them to almost intuitively do what is the right thing for their product. So, any questions?
Thank you very much, Anne. Any questions? Okay, well, I'll kick off if you don't mind.
Okay.
So one of our robust design graduates, the guy who produced these book readers,
yeah.
he's extremely good engineer. He produced his description for this, put all his GD&T tolerances on it, and sent it out to Asia for production. And it came back, and we got some measurement reports done on it. And there was the same tolerance on every single dimension, regardless of whether he tolerated tighter or not.
Yeah.
And because he was a startup, there was basically nothing he could do about it. It was, you've got the product, you've got a launch, you haven't got a legal team to go and fight your corner on these tolerances that you've asked for, they've agreed on but not delivered. I'm just wondering, are these some of the issues that startups face, and is there anything we can do about those concerns?
I mean, the fact is you have to design to the process capability of the company that you're working with. And depending on how you choose your injection molding supplier, that can have a big effect on it. So a lot of it is understanding the capability of your injection molding supplier. So are they able to do it? And it's not just the capability of their parts, but it's also the capability of their measurement system, the capability of their control, etc. So we do, back when I was working with the bike companies, we actually went in and did audits on all the suppliers, but we used very different metrics than you normally would use. And it was sort of a walk-around checklist of, very simple. If you look at the machine, is there actually a settings thing that isn't dusty? Which gives you a pretty good indication of whether or not they're actually picking it up and looking at it. So yeah, a lot of it's just, you can design beautifully, but if you're not designing to match your process capability, there's a reality to it. Yeah.
Just asking all these tricky questions to these new startups, you must get a lot of input. There will be a lot of potential things that can go wrong. So how do you do the prioritization? How do you do the structured approach to working with the really key thing first and leaving the rest for, well, perhaps?
Oftentimes you run out of time. And we just start knocking stuff off. And keeping prioritized lists of these are the top 5 items we need to address, and then they just get redone every single week on the fly. The nice thing that happens in a small group is that if you look at product design and cycle time in a product design is a function of the workload divided by the number of people plus the communication. And communication goes up exponentially with the number of people involved. So when you're working in a small team, it's very easy to get rapid information very, very quickly. And we have daily meetings sometimes. And so the communication flow, because everybody's sitting there, just happens naturally. So instead of it being this long process of everybody's got to get their prioritization and then present and then redo, it just happens very organically because I forgot, I want to go back and look at this study of the airplane that was designed in World War II by the 3 guys for Lockheed Martin. I want to say it was the Comet. Because that small team approach has incredible benefit to being able to look at the whole system.
What's that last question?
Yeah. Just one comment is that looking at the risk perspective and actually finding all this risk from the experience base, and you're asking what is the next? What is the next? We will see. As I see it, the next is we need to actually dare to say how to design, because we're almost saying that it's just a premise that everything goes wrong. So therefore, we need to look a lot to where it went wrong last time. I actually think that is not the case, because if you're a very, very good designer, you will actually, in some aspect, not all aspects, but there's a lot of aspects where things doesn't go wrong. Right. So when you say we are miniaturing the things it goes wrong, you're absolutely right. It goes wrong because they're designing wrong. Yeah. So I think the next step is to use your ideas of putting the right questions, leading the young designer to design in the right way. We should not allow ourselves to say, yeah, but it goes wrong, so let's make a lot of risk assessment. Why? Right. It shouldn't go wrong. It should be perfect. And that is, as I see it, that must be the next step.
So if you look at the way CAD, I completely agree with you. If you look at the way CAD modeling and the capability of anybody to pick up and do CAD modeling is a huge disservice to designers. I agree. Because it all fits on the model. Like it may require an assembly that's impossible, or it could have horrible surfaces. So what would be the proto-mold kind of evaluation for robustness and assembly? So are there ways of thinking about, anybody want the PhD thesis? Right, so what are those things that could highlight and say, do this at your own peril? And what are those rules? And I think some of the design clarity rules are there, et cetera. But you can't give somebody a design clarity rule and have them look at their design. There's just not enough time, and they don't have the experience to be able to map the two. So the ability to highlight or call out in red dangerous behaviors, in the same way that when you've got a CAD model and you show an impact, it pulls up on red. What would that look like to have a robustness red?
Provocative thought. Anna, we're going to have to cut you off.
Okay.
But thank you very much for your
Thanks.